Hey there! Ever cracked open an old piece of electronics and seen those tiny little components? The ones covered in colorful stripes? Well, those are resistors. And today, we're going to learn how to read their rainbow-colored language. Seriously, it's like cracking a secret code that's been hiding in plain sight this whole time.
So you gotta ask, right? Why all the mystery? Why the colorful bands? Why not just, I don't know, print the number right on the side, like 100 ohms or 47K ohms? Seems like that would make life a whole lot easier for everybody.
Well, the answer is actually super practical. For one, these things are often way too tiny for printed numbers to be readable, but here's the genius part. This color code system is incredibly tough. Even if a resistor gets dirty or a little scorched from overheating, you can usually still figure out the colors. It's a brilliant, low-tech solution to a super common problem.
Visit youtube.com/avidsystem and don't forget to subscribe.
Okay, so let's start cracking this code. The best way to think about it is like a language. Once you get the grammar down, you know what each position means and what each color stands for, you can read pretty much any resistor you come across. It's a surprisingly logical system. So here's the basic breakdown. You'll mostly see 4-band or 5-band resistors. For a standard 4-band, the first 2 bands are your digits, the third is a multiplier, we'll get to that, and the last one is for tolerance. For the more precise 5-band resistors, you just get an extra digit. Simple as that. Each band has its own specific job to do. Let's talk about that last band, tolerance. You see, no manufacturing process is perfect. So tolerance tells you the acceptable margin of error for that resistor's value. A 100 ohm resistor with a 10% tolerance is guaranteed by the manufacturer to be somewhere between 90 and 110 ohms. It's basically a measure of how precise it is. Oh, and before you even start decoding, here's a super important tip. How do you know which end to start from? It's easy. The value bands are usually grouped a little closer together. You read from that side, left to right. The tolerance band is kind of the odd one out, hanging out all by itself on the far right. It's usually gold or silver, which makes it even easier to spot.
All right, that's enough theory. You know, the best way to learn any language is to actually start using it. So let's jump in and decode a couple of real-world examples to see exactly how this all works. Here we go, our first patient. It's a 4-bander. Let's break it down step by step. The first band is yellow, which means 4. The second band is violet, which stands for 7. So our first 2 digits are 4 and 7, 47. The third band, orange, is our multiplier. That means times 1,000. And that last band, the gold one, that's our tolerance, which is plus or minus 5%. And there you have it. We take our 47, multiply it by 1,000, and we get 47,000 ohms with a 5% tolerance. See? Simple as that. You just read your first resistor. Okay, let's level up. Here's a 5-band resistor. These are used when you need more precision. The process is pretty much the same. We just have one extra digit to work with. First band is blue. That's a 6. Second is red, a 2. Third is black, which is 0. So our significant digits are 6, 2, 0. The fourth band, brown, is our multiplier, so times 10. And that final brown band, that tells us the tolerance is a super tight plus or minus 1%. So what's the final value? We take our 620, multiply it by 10, and we get 6,200 ohms. That extra band just gives us one more digit of precision before we hit the multiplier. See? You're totally getting the hang of this. Now, wouldn't it be cool to have a little cheat sheet while you're getting the hang of this? Well, you're in luck. The source for this explainer actually has a fantastic little project, a DIY decoder wheel you can build yourself. It's an awesome tool to have around until the color code becomes second nature. And making it is incredibly easy. All you do is download and print the template, carefully cut out the discs, and then pop a little paper fastener right through the middle. In just a few minutes, you have your own physical code cracking tool that makes decoding any resistor super fast. Before we wrap up, I want to show you one really interesting, kind of weird exception to the rule. What happens if you find a resistor that just has one single black band? Is it a dud? A factory mistake? Nope, it's something else entirely. This little die is called a 0-ohm resistor. That single black band means 0. Now, it's not literally 0 ohms of resistance, but it's really, really close. Its job isn't to resist current at all. It's to act like a bridge, basically a jumper wire that's conveniently shaped like a resistor. Why? So the automated machines that assemble circuit boards can place it just like any other component. How clever is that? So there you go. The resistor color code isn't so secret anymore, is it? It's just a really elegant, logical system for putting information right where you need it. And it kind of makes you wonder, doesn't it? Now that you can read this hidden language, what other secret codes are hiding in the technology you use every single day, just waiting for you to discover them?
Thanks for watching.